Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data File Handling, Part 5, for the Class 12 students of Computer Science. In this video, we are going to learn relative and absolute path and standard file streams. So, let's dive in and get started. Let's discuss about files in a computer system. Files in a computer system are typically organized into directories, also known as folders. So, what is a directory? Directories provide a way to group related files together and create a hierarchical structure for better organization and management of files. Every running program has a current directory, which is the default directory for most operations. For example, while opening a file for reading, Python looks for it in the current working directory. In Python, you can use the OS operating system module to work with files and directories. os.getCwd returns the name of the current working directory. Files are always stored in the current folder or directory by default. The OS operating system module of Python provides various methods to work with file and folder or directories. For using these functions, we have to import OS module in our program. CWD stands for Current Working Directory. Let's learn about the file path in data file handling. In Python, a path is a string that specifies the location of a file or directory on the file system. Now, look at this picture. Here, I am working with Python IDLE to teach you the file path clearly, step by step. Now, the Python code written is saved in the directory c:/python/filehandling/files. Now, look at this Python code in the green box in line 1, import OS. This line imports the OS module, which stands for operating system. The OS module provides a way to interact with various operating system functionalities, such as file and directory manipulation. Second line, cwd equals os.getCwd function. Here, os.getCwd is a function provided by the OS module. GetCwd stands for Get Current Working Directory. When you call this function, it returns a string that represents the current working directory of your Python script or program. The current working directory is the directory, or folder, where your script is currently running. The returned value is assigned to the variable cwd. Finally, printf cwd, this line prints the value stored in the cwd variable. The value represents the current working directory, which is the location where your Python script is currently being executed. So, when you run this code, it will import the OS module, retrieve the current working directory using os.getCwd, and then print that directory's path to the console. This can be useful to understand where your Python script is operating and can be particularly helpful when dealing with file and directory paths in your code. You can see the output in the below box. The current working directory is c:/sallyandbytes/python/filehandling. File paths in data file handling can be either relative path or absolute path. A relative path is a path that specifies the location of a file or directory relative to the current working directory. For example, if the current working directory is c:/sallyandbytes/python/filehandling, a relative path to the myfile.txt file in the same directory would be myfile.txt. Relative paths are useful when you need to specify a file or directory location that is relative to the current working directory. Now, we will see about absolute path. An absolute path is a path that specifies the complete location of a file or directory on the file system, starting from the root directory. For example, the absolute path of c:/sallyandbytes/python/filehandling/myfile.txt file would be c:/sallyandbytes/python/filehandling/myfile.txt. Absolute paths are useful when you need to specify a file or directory location that is not relative to the current working directory. Now, look at this picture. A text file named myfile.txt is saved in a Windows path, C drive, c://bytes/python/file-handling/myfile.txt. The green arrow marks the path. When we right-click myfile.txt and then click the properties, we can find the location of the file myfile.txt as shown below. Now, you can see the contents of myfile.txt file. Hello, everyone. Welcome to Sys.Stdn Bytes. Today, we are learning relative and absolute path in Python. Now, we are entering into Python IDLE environment. If Python is already installed in your computer, you can work with it. Or else, install Python in your computer. In the video titled Getting Started with Python for Class 11 Computer Science, you'll find a tutorial on how to install Python on your system. Feel free to access the link provided in the description box below to watch the video. Now, look at the below picture. This is the interactive mode with the command prompt. Now to enter into script mode, click File menu. It's highlighted in red box. Now, click New File. You will enter into the script mode, where you can type data and save it and run the code, and the output displays in interactive mode. Now, we are typing the Python code in the script mode. Look at line 1. F equals open of c://sys.stdn bytes/python/file-handling/myfile.txt, r. This line of code opens the file located at the specified absolute path and assigns the file object to the variable f. The path points to myfile.txt within the directory structure c://sys.stdn bytes/python/file-handling. So this is the absolute file path we have given. This is the completer location of the file, starting from the root directory, C drive. In line 2, data equals f.read function. This line reads the entire contents of the file using the read method and stores it in the variable data. Line 3, print of data. This line prints the contents of the data variable to the console, which is the text inside myfile.txt. Line 4, f.close. This line closes the file object associated with the variable f. Now, look at the output displayed. You can see the contents of myfile.txt file displayed over here. Now, look at the Python code. In line 1, f equals open of myfile.txt, r. This line of code opens the file named myfile.txt in read mode, r, and assigns the file object to the variable f. This is the relative path of the current working directory. In line 2, data equals f.read. This line reads the entire contents of the file using the read method and stores it in the variable data. In line 3, print of data. This line prints the contents of the data variable to the console, which is the text inside myfile.txt. In line 4, f.close. This line closes the file object associated with the variable f. It's good practice to close files after you're done with them to free up system resources and prevent potential issues. Now, look at the output displayed. You can see the contents of myfile.txt file displayed over here. So finally, we are thorough with the absolute path, which is a path that specifies the complete location of a file or directory on the file system, starting from the root directory, in this project, from C drive. And relative path is a path that specifies the location of a file or directory relative to the current working directory. Both gives the same output of the contents of the text file, myfile.txt, as they are in the same directory. Remember, they are in the same directory. Note that the Python program and external file must be in the same directory, else we will need to enter the file path. Here the Python program is in the directory c:\sallynbytes/python/file-handling/file1, and the external file is in the directory c:\sallynbytes/python/file-handling/myfile.txt. Let's discuss about the standard file streams in Python. If someone asks us to give input to a program interactive or through typing, we know what devices we need for it, like the keyboard, mouse. Similarly, in case someone states that the output that to be displayed, we know which device it will display, right? Undoubtedly that will be on the monitor. So, we can reliably say that the keyboard does the standard input device and the monitor does the standard output device. Similarly, any error if happens then determines and also displayed on the monitor. So, the monitor is also a standard error device. We use file objects to work with data file. Similarly, input or output from standard I/O devices is also performed using standard I/O stream object. We can reliably say that the keyboard does the standard input device and the monitor does the standard output device. Since we use high-level functions for performing input or output through keyboard and monitor, such as eval function, input function, and print statement, we are not required to explicitly use I/O stream object. In Python, standard file streams refer to three default streams that are used for input and output operations. They are standard input stream, standard output stream, and standard error stream. These standard streams are nothing but file objects, which get automatically connected to your program's standard devices when we start Python. In order to work with standard I/O stream, we need to import sys module. The methods which are available for I/O operations in it are: read function, for reading a byte at a time from keyboard; write function, for writing data on console, that is, monitor. The three standard streams are described as follows. Standard input, sys.stdn. This stream is used for reading input from the user or from another program. By default, it is connected to the keyboard, but you can redirect it to read from a file or another source. Standard output, sys.stdout. This stream is used for displaying output to the user or sending data to another program. By default, it is connected to the console or terminal, but you can redirect it to write to a file or another destination. Standard error, sys.stderr. This stream is used for displaying error messages or warnings to the user or another program. Like sys.stdout, it is also connected to the console by default but can be redirected. In Python, these streams are represented as file-like objects, which means you can use file operations like read and write with them. The standard way to access these streams is through the sys module, which provides access to various system-related functionality, including the standard streams. You need to import the sys module to use them. Let's see how you can interact with these standard file streams. In order to work with standard I/O stream, input-output stream, we need to import sys module. For standard input stream, we use sys.stdin.read function, or you can use readline function also. For standard output stream, we use sys.stdout.write function, and for standard error stream, we use sys.stderr.write function. Let's see an example. Program to check if division is possible using standard file streams. Now, look at the Python code. In line 1, import sys. This statement imports the sys module, allowing you to use its functionalities. In line 2, sys.stdout.write enter the first number. This line uses the write method of the stdout stream to display the message enter the first number, without adding a new line character at the end. In line 3, n1 equals int of sys.stdin.readline function. This line reads a line from the stdin stream, standard input, using the readline method, converts it to an integer using the int function, and assigns the result to the variable n1. In line 4, sys.stdout.write of, enter the second number. This line similarly uses the write method of the stdout stream to display the message enter the second number. In line 5, n2 equals int of sys.stdin.read line function. This line reads another line from the stdin stream, converts it to an integer, and assigns the result to the variable n2. In line 6, if n2 equal to 0. This line checks if the value of n2, divisor is equal to 0. In line 7, sys.stderr.write of, can't be divided. If n2 is equal to 0, this line uses the write method of the stderr stream to display the message can't be divided. The stderr stream is typically used for error messages and highlighted in red color in the output. In line 8 and 9, else. If n2 is not equal to 0, this line starts the else block. sys.stdout.write of, division is possible. Inside the else block, this line uses the write method of the stdout stream to display the message division is possible. You can see the output. We enter the first number as 54 and the second number is 6. As the number is divisible, the message displays division is possible. Now look at the right side output. We enter the first number as 54 and the second number as 0. As it can't be divided by 0, error message in red color is highlighted as can't be divided. Let's see another Python code. Program to open a text file and read a content using standard file streams. In line 1, the import sys statement is used to import the sys module in Python, which provides access to system-specific parameters and functions. In this code, the sys module is used to interact with the standard input and output streams, as well as the standard error stream. In line 2, sys.stdout.write of, enter the text file to be opened. This line uses the write method of the stdout stream to display the message enter the text file to be opened, without adding a new line character at the end. This prompts the user to enter the name of the text file they want to open. In line 3, fname equals sys.stdin.read line. This line reads a line from the stdin stream, standard input, using the readLine method and assigns it to the variable fname. The user's input is expected to be the name of the text file. In line 4, f equals open of fname.strip function, r. This line opens the file specified by the user's input, stored in the variable fname in read mode, r. The strip method is used to remove any leading or trailing white space characters from the file name. In line 5, while true : this initiates an infinite loop, which will keep reading characters from the file until the loop is explicitly broken. In line 6, ch equals f.read of 1. Inside the loop, this line reads one character from the file using the read method with an argument of 1. The read character is stored in the variable ch. In line 7, if ch equal to empty string. This line checks if the value of ch is an empty string. If it is, it means that the end of the file has been reached, and there are no more characters to read. In line 8, sys.stderr.write of end of file reached. If the end of the file is reached, this line uses the write method of the stderr stream to display the message end of file reached. The stderr stream is used for error messages. In line 9, break. This keyword breaks out of the loop when the end of the file is reached. In line 10, else. If the condition in step 6 is not met, this else block is executed. In line 11, sys.stdout.write of ch. Inside the else block, this line uses the write method of the stdout stream to write the character ch to the standard output. This effectively prints the contents of the file character by character. In line 12, f.close function. After the loop, this line closes the file that was opened earlier. Now look at the output. The user enters the file name as myfile.txt. The contents in myfile.txt is completely displayed in the output. Hello everyone. Welcome to Sally and Bytes. We are working with standard file streams in Python. Finally, the error message is displayed in red color. The message is end of file reached. Thanks for watching. Watch the upcoming videos. Data file handling part 6. Binary files, pickling and unpickling. You can check the link in the description box below.